Hi everyone, tonight we have a special video. We have our very first M1 MacBook Pro in for board repair for data recovery purposes. You may be wondering, why isn't the customer just going to Apple for a warranty board replacement? Well, they have important data on their machine, and unfortunately on any of the new machines, if your board fails, your data is gone unless you could find someone who could properly repair the board. Since the storage is actually these two chips right here, these two NAND chips, so soldered to the board, underfilled, so it's not like an SSD or hard drive you can just pull out and get your data off of. If the board fails, you're kind of out of luck, again, unless somebody can repair your board. So let's see what this does. So we're going to plug in our USB-C charger, plug it in. Let's see. All right. Looks like we get 5 volts on the charger, almost 100 milliamps, and the fan is running at 100% speed right from the start. So I unplug it, plug it back in. The fan doesn't ramp up. It just immediately spins to full. So typically that means there's something wrong on the SO rails. We have no schematic. We have no repair information. So this is going to be a pretty interesting learning curve here. So anytime we see something as high as like 100 milliamps on a board that's not booting, that's typically a short somewhere. So let's go ahead and get this board out, and then let's have a look and go from there. Alright, our logic board is out. Let's go ahead and jump right into this and have a look under the scope. I'm actually pretty excited to see what we're going to find here. So let's see, switch over to microscope, and let's just give it an overview. So, you know, on anything like this, what I always recommend people do, just give it an overview under the microscope. See what you see visually if there's anything wrong, and that's usually your telling factor right there. I mean, you'd be surprised how many issues that can be solved by just looking. Even complex issues, you could usually just see them. So far, this is very clean. I mean, this design feels very much like other boards. There's differences that I see. The charge controller is the same circuit, it looks like. Much of this is copy and paste from 2159. That's different right there for sure. Backlight circuit looks the same. They pretty much had that for a long, long time. USB circuit looks... Wait a second. CD3017B12. But if you notice something, this right here... Yeah, I'm pretty sure you're not supposed to be able to do that on a chip. Like, yeah, that you're not supposed to be able to do that. You're not supposed to be able to just flick up a piece of the silicon and see the die. That looks abnormal. And I think this is our problem, just by visual inspection. So, first off, the likely cause of this is somebody plugged in some lousy USB device or a lousy charger, because this generally won't just happen by itself. It can happen by itself, but most likely the cause of this is somebody using a lousy charger. So I'm going to go ahead and pull this chip, taking note of the orientation. The dot is in that corner. Let's go ahead and put some flux around it. Don't really need that much, so I don't really plan on ultrasonicking this. CD3217 is off. Let's wick this area a bit, and then we'll grab a new one. Or a reballed one, I should say. Because those aren't really available just yet. So I'm just going to get all that lead free off. Some wick. clean it up, have a look. It should be good. Alright, we're ready for our new chip. Let's put a little bit of flux down. I don't want too much because sometimes when you put too much flux on BGA chips, it kind of gives the chip a tendency to float away, and that's not what I want. These CD3217s are already really hard to align just because of the weird BGA pattern that they used on it. I don't really know why they went with that pattern. There's no functional difference from a normal pattern or anything, so just a case of engineers being engineers, if you know what I mean. Alright, spread out. Let's go ahead and grab our chip. And the alignment mark is going to be like this. Let's get it as close as we can to the positioning of the other one. So I'm going to use the other one as a reference to line it up. That's pretty close. Now what we're going to do is go ahead and move in with our hot air. I'm going to go with a low airflow. I want like 430 degrees and like we'll do 40 liters per minute because I don't want to blow the chip away. Flow into place, come on. And it's in place. Gonna let the board cool for a little bit. And we'll test it, but it looks like it's decently in place. And aligned nicely as it should be. Just go clean around here while we're waiting for it to cool down. We don't want to put alcohol on the chip right away. That would be bad. Alright, now let's see if it actually turns on and gets 20 volts here. So let's grab our USB-C port. Alright, let's plug in our charger with USB amp meter right here so you guys can see it. This was the port that was exploded, so let's use that one. Let's see what it gives us. Still nothing? Let's see, what does this one do? So it looks like it's still staying at 5 volts and 51 milliamps, and this one port has nothing. Let's reverse it. Wonder if there's an LDO or something shorted in that circuit. Alright, this side works. I wonder if that's normal. We don't know how these new machines work. So let's go ahead and put this back in the enclosure and we will go from there. And one thing I noticed Because there was a screw stuck right here, which is very strange. That probably happened when I took it apart, but that's odd. So let's set this back in the enclosure and see what it does if there's anything different. So I want to make sure I plug in everything because we don't know what's essential and non-essential on this machine. For all we know, that the processor sees something unplugged and says nope, we're not turning on. And the charging circuit may be set up differently as well. So we're going to plug in everything. Need the screws for the battery. Where's the screws? Here they are. Alright, let's plug in our charger, see if there's any difference in symptoms. So, guess it would help to actually plug the port in. Let's try this side, nothing on this side. So something is still up in that circuit, I'm guessing. And our fan did not go to max, so that's a start. But I also have no trackpad click and nothing further in the power up sequence. And 51 milliamps is still a little bit high for the board doing nothing. So if the board is doing nothing, 51 milliamps still seems like quite a lot. So I'm just going to probably do some thermal imaging here. Let's see. See if anything abnormal is getting warm, and I don't see anything except this area right here, which I'm guessing is going to be the T2 chip. Let's take up that, wait, this doesn't have a T2 chip. That's right, it's M1. So let's take up this shield right here. Let's see what's under here. It's a little bit warm. It's not overly warm, just slightly warm. But let's see what's under there. Let's go back to scope view. My scope is acting really funny here. Let's see. Alright, that's better. So what is going to be under this shield? Let me unplug the battery. Ah, they have capacitors under here. So, let's check for a short. So they have, you know what this is? This is going to be the power phases for the CPU, it looks like. That, I'm willing to bet, is the PMIC. That's an Apple chip, obviously. It's got an Apple on it. So that's probably going to be the PMIC. And there's a lot of traces right here. These traces look like they handle a lot of power, and I'm guessing that's going to be for the CPU power phases right here. That's what makes sense to me. So if this is getting warm, that concerns me for a possible short to the CPU, which would be lovely. So let's plug in the charger again, and let's see if anything notably gets warm under there. I don't see how that would affect it. I mean, it could very well be just the T2 chip saying, hey, you know, I'm getting, not the T2 chip, M1, sorry. Just feeling, I don't feel anything getting too warm there. Unless it's on the other side too. Let's get some thermal imaging here. Nothing is overly warm. Let's pull the board and do the other side. I'm kind of thinking that there's going to be an LDO short. Let's try on the other pin, just to rule it out. On the other port, I mean. And there's warmth, but it's not. Yeah, there's some definite warmth here. It's hard to see because I can't really show you guys here. It's not like crazy warmth, but there is definitely definitely some warmth here. All right, let's see if you guys can see. So it's probably really hard to see, but there is a little bit of warmth right there by these capacitors. Doesn't look like it might be on the other side of the board too. That's the thing, I can't really tell. So let's get this board out and have a look. Again, this is probably going to be a long repair video because we do not have any schematics. We have no board views, nothing like that. So we're kind of going off of just what we know already and kind of piecing together the puzzle for these new series boards. And this board is actually an 820-2020. Now, I don't know about you, but naming a board after such a lousy year is kind of probably not the best idea. Tends to bring bad luck. That number's bad luck. So hopefully these boards hold up. But since first one and only 4 months in, I don't have high hopes. We'll see though. This is surprisingly not very iPhone, if you guys know what I mean. Like a lot of the new boards are very, they share a lot of characteristics with the iPhone, and this is really not like that. This is more like a laptop board than anything. So directly on the other side of these caps, looks like there's nothing. There's a little controller here. So let's have a look. I'm going to probe around the CD3217 too. One possibility is that would generate heat is if that controller, that Reneus controller, whatever it is that we looked at earlier, if that is for the PP3V42 G3 hot circuit, then that could very well be getting hot under load if there is a shorted capacitor around the CD3217. I'm referring to this chip right here. It doesn't look like it though. I'm willing to guess that's the driver for the CPU MOSFETs right here, now that I think about it, but let's see. So let's go back under the scope. Yeah, so these guys right here, I'm willing to guess that's the driver here, but something was definitely getting warm here. So let's just probe around the CD3217 and see if there's anything that's shorted. Let's grab my meter. Interesting. So our DC in circuit is shorted 53 ohms to ground. I'm guessing this is the DC in fuse right here. To previous models, this was the DC in fuse. So 51 ohms to ground is way too low resistance for something like DC in. The charger is not going to like that at all. So my guess is we got a short somewhere. Well, we know we have a short somewhere. It's a partial short. Let me plug in the charger and let me do some thermal imaging to see if there's anything on this side that's getting hotter than it should be. And yes, there's two things that are heating up, very, very plain as day. The first one we have is going to be the CD3217 we just replaced, and the other one is going to be this controller for what I presume is the CPU. Let's see if you guys can see this. That in and of itself does not necessarily mean that either chip is bad. Yeah, you guys can't see it. But there's two chips very clearly getting hot. The CD3217 is 150 degrees, and the other one's also pretty hot, 154. So that in and of itself doesn't mean they're shorted. What it could mean is that they're supplying power to something that is shorted. That's my guess. So let's go ahead and try and inject a little voltage and go from there. Let's see. Let's go back to our microscope view. So what I'm going to do is inject some voltage here and see if we can confirm it. Let's see. I want to see what chip this is and what it does. Let's Google. Knowing Apple, I'm almost certain it's going to be locked down, but we need to find that. So let's see. It is I think Rheneas and Intersil are the same thing. I'm probably not pronouncing that right. Rheneas or what? Rheneas 501 CR0B. And the only thing I found is an iFixit guide, which is not going to have what we need. So we have no idea what this is. We cannot get it. It's locked down as usual. So let's inject some voltage on DCN and see what we find. I don't think it's bad. I really don't think it's bad. I think it's an LDO or something around here somewhere is pulling too much power from something. Like nothing seems shorted in the usual areas. Except this. This is 28 ohms. This ain't right here. Alright, this capacitor. Let's just move it to the side. Just want to rule it out. So I'm just going to move it like that so we don't lose it. And now I'll probe DCN again to see. Alright, still shorted. And that's still 9 ohms to ground. This other CD3217 may be bad. Alright, let's inject to DCN. Actually, let's see if we have a better point other than that fuse. I'll use the fuse. It's not really going to be under the scope that well. The wire doesn't really reach all that far, and plus it's going to be through thermal imaging that we're going to make the diagnosis, not over visual. So I'll show you guys the best I can. Let's get some solder in here. I hope they didn't like run the CPU power off of DC in or something. That would be a disaster. All right, we're gonna put in our lead. We're gonna start at 3 volts, and at 3 volts we're pulling nothing. It's up at 4. At 8 volts we're pulling half an amp. And I'm all the way at 15 volts. And nothing is getting hot except this. Yeah, the only thing that's getting hot is the CD3217s and this chip right here. This Renesas chip or whatever, this is getting blazing hot, which is abnormal. I mean, that doesn't make any sense to me why that would be getting hot. Because that's for the CPU, I believe. Unless it's for PP3V3G3 hot. Again, I don't know. Like, that's, yeah. I want to see if there's anything around it. Well, one way is take this thing off and see if any, if the shorts go away. So, just, it's odd. That's a very odd presentation that the CD3217s are hot along with that one chip. So, we may have a multi-issue here. Let me just look and let's take off the heatsink. Let's see if the CPU has like a burn mark or something in it. That's something that would always happen on the Intel chips. Whenever they would get a spike, the die would blow off or something. So I just want to pull the heatsink off and have a look and see if there's a scorch mark or something on it. That way we don't waste any more time. Big CPU. Honestly, this is like almost bigger than the Intel CPUs. And I don't see anything that concerns me here. Let's clean off the thermal paste. Yeah, there's nothing. The entire CPU is underfilled. So this I like and I hate it at the same time. I mean, nobody's going to change this, I don't think. But you're going to get morons that heat them up and stuff, and that's going to ruin it. And it will protect it from liquid, so I got to give it that. So I don't think this CPU is dead whatsoever. I don't think there's any issues here. Like on the Intel chips, we would see scorch marks or something. You just don't see that here. So I'm going to take off this one QFN chip right here that is getting burning hot, and we'll go from there. The problem is we can't get that because Apple does not supply that. It's locked down from the manufacturer. The configuration looks a lot like something that would be used for the CPU. It looks like a buck converter. So that could be the case or not. We don't know. Could be a controller for the 3v3 G3 hot. I don't know. Again, we're gonna take it off. It's pretty suspicious due to its positioning that it's for the CPU. Another possibility is they're using the RTC line again to power the CD3217s, and that would make sense that this would be spitting out that line too, and it's just getting overly hot from increased load from a short. So I do not want to lose this. I'm just going to put it aside. We're going to check for a short and see if our short is still there. And if it is, we're going to take off this other CD3217 and try it. We should actually get these new boards. Some of them will turn on without a CD3217. And we still have the same short. So my best guess right here and right now what this is, and given our current findings, since we have a shorted capacitor with a kind of a short on it near the other CD3217, my guess is that they're using the same buck converter IC to power the CD3217s. So if something is using too much power on the CD3217s, that chip is going to get blazing hot because there's an increased load on it. So I'm going to pull off this other CD3217 and see if the short resolves itself. And then we'll try and turn it on, and then we'll replace the other one. The CD3217s are very scarce. You can't really find them. So I will have to find another one, and that may be difficult, but we'll get it done. So let's go ahead and take off this one right here. Some flux around it. I want to make sure to move this capacitor back over as well. That's off. Let's check for a short now. And what do you know? No more short. So, yep, no more short. Okay. So we need another CD3217. This one is for sure bad. I want to see if this boots. So I'm going to put this other chip back on. And I want to see if it boots. Alright, that one CD3217 has been removed, and we still get the same symptoms. This one IC still gets burning hot. So let's probe around this and see what we find. No short, and this one is 50 ohms to ground, so 50 ohms. And I think that was similar to this right here. No. No short on DCN anymore. That's 50 ohms. What's going on with our meter here? Okay. 50 ohms, 0 ohms, 0 ohms. So there's a short on this line. You know what? Let's see if we can find PP bus. PP bus right here. And there's no short on PP bus. So it's not a PP bus short. This is bizarre. So let's inject a little bit of voltage on this line, and let's see if what boils. So I'm going to put some alcohol around this chip so you guys can see it. And to those that are new to electronics repair, no, this will not hurt anything. Using alcohol or distilled water for diagnosis purposes like this is not going to damage anything whatsoever. Totally normal, totally accepted diagnostic practice. Let's turn on our power supply. Let's start at like half a volt because I don't want to damage anything. So we're going to be really careful and start at half a volt and see what boils. Because something is probably at 0 ohm, something is going to... We're pulling over an amp. It's this chip right here. This is shorted. So my only guess is this had some spike on DCN, and this had to have killed this chip. Let's go up to 1 volt. 1 volt's not really going to hurt anything. So there had to have been some spike on DCN. Yep. Look at that. There had to have been a spike on DCN, and that ended up killing this right here. Now, like I said, can't really find these yet, so let's take this off again. And let's see if our short is resolved around that IC. This is still 50 ohms. That might be a CPU line or something, I don't know. But the short is resolved. So my guess, like I said, is a spike on DCN. So we need a new CD3217 right here. We need a new one of these. So I'm going to go ahead and find those and then update this video when I do. There's really not that much information on this machine since it's just brand new. So I'll have to do some hunting for that IC and then we will come back to this. Okay, we have our new ICs in. They're pretty hard to get, at least the Renesas chip was. I had to find somebody that had an iCloud locked board in the repair industry that was willing to pull it off. So hopefully, as time goes on, these become more available, but I don't have high hopes. I'm pretty sure Apple locked down the supply chain on this like they did the CD3217 and ISL 9240, which is plain wrong. But anyway, let's go ahead and get this chip installed on the board. It's in place. Now let's go for our CD3217 here. We gotta wick these pads away a little bit. Now I can never really point this out enough. Do not use pressure when doing this. Just kind of rest the iron on the wick and drag the wick, or else you will rip pads. It's super easy to do it, especially on the CD3215s and CD3217s. And if you do, you're gonna have a really fun time running a wire under this chip. So. And that should be good. I'm not too concerned about that right there. Let's go ahead and get a little bit of flux on this. A little bit more flux, actually. Let me clean up some of that burned stuff. We don't want that there. And our new CD3217, or reballed CD3217. And look at this, it's actually a different, looks like a different chip. I mean, it's the same chip, but it's different. You can tell the difference in manufacturing there. Different style. Same chip, different style. Probably different factories or different date codes. They should be fully intercompatible with each other. Let's give that a second to cool down. Alright, let's plug in our USB-C port. And let's see if this actually works. So let's grab our USB-C amp meter, plug it in, and see if we get 5 volts or 20 volts. Now, I don't know how these are set up because they're so new, so we will see. 5 volts, 0 amps. 5 volts, 10 amps. And it's cycled. Let's try the other port. And the processor is hot. So I don't know if that's a good sign if the processor is hot. Let's see if we have any rails present. So let's try measuring PP bus. It's also possible these need to be in the enclosure to work. I mean, it's such a new device. So some of them are like that. And PP bus is present at 12.31 volts. And it dips down to like 10 or 11 for a brief second. And the processor, I mean, the processor is visibly warm. So that's not a sign that I like to see whenever a CPU is warm when the board is not doing anything. But let's go ahead and test this in the enclosure just to rule out everything. Since PP bus is present, maybe it needs to see a battery or something like that. So let's go ahead and throw this in the enclosure and see what it does. Alright, the device is back in the enclosure with the battery connected. Well, we're about to connect the battery right now. And let's see what we get. Five volts, 20 volts. Okay, so we're getting 20 volts, 19, 34 milliamps. That's booting current. And we have an Apple logo, but we can't see the Apple logo. Looks like there's no backlight. So that's interesting. Let's see what I can see. If it boots or whatever it does. You can definitely see an Apple logo in there. Let's see. I don't know if the camera can see it. But there's definitely an Apple logo. Alright, we're at the login screen. I could see from the login screen. I'm wondering if the brightness is just set super low or something. Let's see. Maybe if I get my phone light, shine it over here, you guys can see that this does indeed boot. Alright, look. Let's see, glare. Yeah, see that? You can see the login screen right there. So this is booting. But there's no backlight. So this is going to be an interesting experience. So the first thing I want to do, let's see what backlight output voltage is. It's entirely possible it's something simple, or Apple did something really cruel and restricted, like unplugging something, or it knows when the screen is unplugged, or some nonsense like that. I think that's very unlikely, but let's see. We know backlight output voltage is going to be on these capacitors right here because that's the same as it was prior. 0 and 0. So we have 0 volts on both. 12.84 volts on one side of the fuse, 12.84 volts on the other side. Alright, so there's no backlight, most likely no backlight enable. So let's go in here. Let's have a look. One thing I want to try, the PRAM reset, but I don't think... Alright, it just restarted. Alright, let's restart it now. And we have chime, no backlight. This is weird. I feel like this is something that's probably going to be software. Alright, we're back at the login screen. Let's try something simple. Let's reseat the screen connector. So battery is unplugged. Screen connector is visually fine. Let's plug it in, make sure it's seated really good, and it is. So let's talk about backlight being 0 volts. A short on backlight output is plausible, or the backlight circuit's not getting enabled. Now, I don't think I can check enable here because we do not have a schematic, and we're still at 0 volts. Alright, let's go ahead and give the backlight circuit a little look over. Let's see. So let's check for a short on backlight output. So that's going to show up on these capacitors right here. I know that from experience. This side, no short. That side's ground. No short, no short. Driver looks alright. You guys see what I see? Look at this. Now we have no idea what value this resistor is, but this resistor looks like it has a hole in it. So this likely blew for some reason. I don't know why that blew, but that looks like that resistor looks blown. So on this machine, we have no schematic, we have no board view, we have nothing like that. So we're going to have to make an educated guess at what value that resistor is. And one thing we could actually do is look at the year's prior board, which is going to be an 820-01598. So let's do that now. And let's see if we can find a similar resistor here. So 820-0598. And let's find the backlight circuit on this board. And it does not look like it is remotely close. It looks like it is going to be, let's see, opposite side of the board. Okay, here's our backlight circuit on the previous generation 2019 Intel model. That's almost the same board. So here's our backlight driver right here. Now if we look at the M1 board, what we can see is that the dot on that chip is at the bottom. So the dot is going to be pin 1. So if we look at our display capture, we could see this is going to be pin 1. And now we notice we have a capacitor here, and then we have our PP5VG3S coming in, and it looks like this goes to PP5VSO backlight. And on the schematic, let's do a search and let's see what this actually does on the schematic. So here's the schematic. P5V, what resistor number is that? Yeah, right here. That's going to be the VDD and VDDA, so that's going to be the voltage input on the chip, or one of the voltage inputs on the chip. And what value was that? That was a 0 ohm resistor, so it's essentially a jumper wire right there. Now, if we look at this, this resistor leads to the second pin from the end is unconnected. Second pin, and then one thing I noticed on the other board is this capacitor is also connected to that chip, and it looks like on this board it goes to the third pin in. So third pin in from this side and second one from this side. Let's have a look at this board over here. So here's our board, and it looks like we've got to put this at an angle to see it. And it does look like one side goes to the second pin. Let's see. Yeah, one side goes to the second pin and the other one goes to the third pin in. So that is my guess, is that's what these lines are going to be for right here. Let's go ahead and try a 0 ohm resistor there. One thing I also want to check, let's see what voltage is on that other side of the resistor right there. So on the other case, on this other board, it's going to be PP5V G3S. We don't know if that rail exists on this board. It could be totally different. G3S is essentially a G3 hot rail, meaning always present, always on. So they may have a different rail powering it, or the same. My guess is it's going to be either off of another 5-volt rail or a 3.3-volt rail. That's most typical anyway. But we're going to find out. Just plug the battery in. I'm going to plug in the charger, and let's measure. We have 20 volts, and we have booting current now. And we have 2 volts. 0 volts, 2 volts. That's kind of strange. I wouldn't expect that to be 2 volts. Went down to 1.9. 2-volt rail? I don't know. That's a bit bizarre. Just check for a short on that side just to be safe in case it is 5 volts and being pulled down by something. They might have like a special backlight rail or something. My other concern is this driver may be dead as well. Sure, no power is connected. And that's 17 ohms to ground. That's a bit low for my taste. So 17 ohms to ground. This is probably a 5-volt rail, and it's being pulled down. So let's go ahead and find our short there. I'm going to start at a very low voltage here because I don't know where this is coming from. I mean, like I said, this whole device is a learning curve because there's literally no information out there on it. So I'm going to... We're going to only inject half of a volt for right now. We'll see what amp draw is, and then we'll go up. We know we could at least safely put 2 volts there. 1 lead on ground, 1 lead right here. And that's pulling nothing. I wonder if they're running it off like the processor power or something. We know they're doing USB like that, so let's go up to 1 volt. .8 volts. Yeah, there's no parasitic amp draw there. Alright, it must be a low resistance line. Let's go ahead and grab a 402 1 ohm resistor and let's put it in. I'm not going to take the board out. I'm just going to switch to a smaller nozzle and we'll see if it works or what happens. So let's grab a resistor right here. Being very careful not to heat anything else in this area as well. We don't want to kill anything. And that capacitor came off. That's not too important. We'll just steal that from another board as well. If we can't find it, that happens. Capacitors I don't really worry too much about. And actually, it's right here. So we don't need to. All these are really for is just to smooth out the voltage a bit. It's not critical or anything. Now for our resistor, I'll get a little bit leaded solder on there just to help it flow into place a little bit easier. We'll clean that up when we're done here. It'll look just fine. Reason why I say that is when we heat that capacitor, that little bit of solder is going to go under it, and then we'll clean up anything that's left over when we're done, and it will not look like a disaster like it does now. One side, this resistor doesn't want to be just like that. Looks perfect. Alright, our board is back in the enclosure, and as you can see, this is a booting fixed M1 MacBook Pro. I don't want to reveal the customer's name, but this turns on, the trackpad works, typing works, all of that. So this should be good to go. We learned quite a bit on this. So now measuring PP 3V or the input to the backlight circuit, it's 5 volts now, which is really strange. It was 2 volts prior, so what that makes me think is if it doesn't sense a load on that line, then it will not go to 5 volts. Again, I could be totally wrong about this. We don't have schematics yet. But this is fixed. So to go over what we did and what was wrong, so came in with no power, 0 volts on USB or 5 volts on USB-C with high fan speed. Under visual inspection, the USB-C controller is visibly exploded. We replaced that one. We realized we had another short on the one right next to it, as well as the Renesas or whatever it's called. Power IC, which possibly powers the CPU V-core regulators as well. That was shorted. We replaced that, and then we found a corroded or a blown resistor on backlight, and we replaced that. And this is a fixed machine. So I hope this video helps us in the future solve these problems when we start getting more of these devices on. And that's it for today. This is fixed. Thank you for watching.